video is just a very simple, very brief stoichiometry review. It's meant to supplement the titrations video, or to be reviewed before the titrations video for the water hardness lab. And so I'm just going to go right into it. So what is stoichiometry? What is that weird, complicated word that sounds like something I should have remembered? Stoichiometry was just, earlier in the semester we learned how to balance equations, and we learned that the balanced equation is, the coefficients represent moles, and it takes, this many moles of reactants to make this many moles of product. So if I'm given a certain number of grams of reactant, how does that relate to my moles or grams of product? How much am I going to get out of that? And that's all stoichiometry is. It sounds like this big, intimidating word, but it's just stuff we've been doing. And so I really like food. I really like to eat. And so I relate stoichiometry to cooking. So the balanced equation is your recipe, so to speak. And that relates the amount of ingredients, or how much flour or milk you need to make this amount of cake or your product. So if you're only given a certain amount of one, how much cake do you get to eat? And so our first very simple example is actually related to cooking and a recipe. So according to my recipe, it takes 2 cups of flour and 1 cup of milk to make 3 cups of cupcake batter. I know that's a lot of cups going on. I have plenty of flour to make the cupcakes. So that's going to be my excess reactant. But I only have 300 milliliters of milk, so that's going to be my limiting reactant. So how much cupcake batter will be made from 300 milliliters of milk? My first step is to have an accurate recipe, or a balanced chemical equation. And so I'm just going to write out that it's going to take 1 cup of milk. Oops. 1 cup of milk plus 2 cups of flour goes to 3 cups of cupcake batter. When you read the back of your recipe box, it actually tells you the number of cupcakes, not the cups of cupcake batter. But because I'm trying to take the approach of using this moles of this gives you this moles of product, I wanted to keep everything in cups. And eating cupcake batter is totally awesome, especially, my mom would make cupcakes. I would try to swipe the bowl before my brother got it, so I wouldn't have to share. So, cupcake batter is great. So we're going to go on to the second step. My recipe relates the amount of flour and milk, like I just stated, in cups needed to make the amount of cake in cups. So, I was given my amount of milk in milliliters, so I have to convert from milliliters to cups. And this would kind of translate to an actual chemical reaction. If you're given grams, you have to convert that to moles in order to use your balanced chemical equation to relate the amount of reactant to the amount of product. We're going to do a real practice problem. And so, but for right now, we're going to convert this milk, 300 milliliters of milk, to cups of milk. Alright, so my conversion factor, literally just pulled it off Google. 1 cup equals 236.59 milliliters. So I have 300 milliliters of milk. Milk. And there 236.59 milliliters in 1 cup. And so my units are going to cancel. Milk, milliliters, milliliters. I'm going to end up with cups. And that's going to be 300 divided by 236.59. That's going to be about 1.26 cups of milk. So I'll just say 1.27 cups of milk. So that's how much milk I got in my fridge. So our next step, I'll write my answer down here. 1.27 cups of milk. So now I can relate the amount of milk I have to our recipe. And I'm just going to write down the equation again. So it was 2 cups of flour plus, I'm going to abbreviate this time. Oops. I'm going to abbreviate this time. 2 cups of flour plus 1 cup of milk give us 3 cups of cupcake batter. And so I have 1.27 cups available. So how much batter can I make with 1.27 cups of milk? And so here we're just going to say 1.27 cups of milk. And so I want to end up with cups of cupcake batter, right? And we're not worried about the flour because the flour is our excess. We're not going to run out of that. But we're going to run out of our milk, which is why it's our limiting reactant, and that's what's going to limit how much product we can make, or how many cups of cupcake batter we can get. So in order to get cups of milk to cancel, I have to have cups of milk in my denominator, and now I'm using my recipe or my balanced chemical equation here. And so I have, for every 1 cup of milk, I'm going to get 3 cups of cupcake batter. And so my cups of milk are going to cancel. I'm going to end up with cups of cupcake batter at the end. So 1.27 times 3 is going to be about 3.81 cups of cupcake batter. So just a brief summary of what we did. We had to figure out what our balanced chemical equation was here. We had to go through and take what we were given and relate it to the moles or cups, in this particular case, of what our recipe called for. And so we had to convert. And once we got into the units we needed here that related to our recipe, we could use our recipe to figure out how much of our product we're going to have. And so that was, kind of weird and quirky, but pretty straightforward, right? And so the next problem we're actually going to do is going to be an actual reaction. And so Mr. LeBennett is giving extra credit. Giving, right? No one ever gives extra credit. You actually have to earn it. To the first student who can get 20 grams of sodium chloride from a reaction of hydrochloric acid with excess sodium hydroxide. How much hydrochloric acid do you need in milliliters to get that extra credit? And so, this problem, I was very nice. I told you I told you what the reactants were. You didn't have to figure out the name from the formula from the name. Gave you one of the products, and so it's easy to figure out what the other one is. And so you also know what the limiting reactant is because you have an excess of sodium hydroxide. The limiting reactant has to be hydrochloric acid. And so we're going to keep these things in mind as we go along. First thing we got to do, though, before I get too ahead of myself, is we have to have balanced chemical equation. We got to figure out what our recipe is to get our sodium chloride. And so our reactants are hydrochloric acid plus sodium hydroxide. And if you can't quite remember, well, what am I supposed to do here to get my products? What goes where? I did tell you that one of the products is sodium chloride. And so if the sodium goes with the chloride, then the only thing left is for the hydrogen in the OH group to make water. And so we're going to have sodium chloride plus water. Okay, so and our equation's already balanced. Try to draw that a little bit better. And so again, it's understood that these are 1-to-1 ratios. So you don't have to write this, but I just like to write it out front to remind us 1 mole of this is going to give us, 1 mole of our reactant is going to give us 1 mole of our products. To let us not forget what those ratios stand for, what they mean. And so we're given grams of product. Mr. Lebenis lets us know. I want you to come back, and when you put your product on that scale, you better say 20 grams. And so, okay, well, I need to figure out how much hydrochloric acid I need, right? But first, we have to figure out, well, in order to relate that to our recipe or our equation, we have to do 20 grams, and we have to convert that to moles because our coefficients do stand for moles. So 20 grams of sodium chloride, and then we want to end up with what moles of sodium chloride, right? So 1 mole of sodium chloride, and let's see grab our periodic table, figure out how much 1 mole is going to be. So sodium 22.99 plus chlorine 35.46. So I got 58.45 grams. And it may differ slightly depending on your periodic table, how you round, what kind of, how far your calculator rounds, things like that. So it might be just a little bit different. Alright, so my units are going to cancel. Grams of NaCl, grams of NaCl. So I'm going to divide 20 by 58.45. I'm going to get 0.342 moles of sodium chloride. So Mr. Bennett wants us to have 0.342 moles of sodium chloride. So I'm going to copy that down here. Now that I have moles of product that I need, I can use the chemical equation to find the moles of hydrochloric acid I'm going to need. And so I'm going to be the equation again. So again, you don't have to write the one. It's not necessary. Or you can write it if you want to just have that reminder that it's already balanced, and since it's a 1-to-1 ratio. And so I have 0.342 moles of NaCl product. And you might be saying, well, in our last silly cupcake example, we had to figure out moles of product, but now we're given moles of product. So, what in the world? Well, because we have our recipe, we can say, okay, if I need a certain amount of product, if I have to end up with a certain amount of product, I can figure out how much of my limiting reactant I'm going to need. That's the beauty of the balanced chemical equation. So 3.2 moles of sodium chloride, and so for every 1 mole of sodium chloride product we get, it took 1 mole, here I'm using my balanced chemical equation, 1 mole of hydrochloric acid. And so really, it's going to take the same amount of moles not NaCl, because that canceled. Excuse me. Hydrochloric acid. Moles of NaCl canceled. That's what I wanted. I wanted to end up with my moles of hydrochloric acid. And now we have to go from moles of hydrochloric acid to milliliters of hydrochloric acid. And so one thing you might ask is, why do we need to figure out milliliters? We can just figure out the moles, right? But if you're actually working in a lab, unfortunately, graduated cylinders and micropipettes and things like that don't measure in moles. They measure in milliliters or microliters. And so you have to have a volumetric unit to be able to measure it out. And we're trying to get that extra credit because you got to be the first student to get it, right? So we have to convert moles of hydrochloric acid to milliliters of hydrochloric acid. And so we're going to go from moles to grams to milliliters, and we have a conversion factor. Once we get to grams, 1 gram equals 1 milliliter. And so I have 0.342 moles of HCl, and I want to go from moles to grams, so 1 mole of hydrochloric acid. For my periodic table, I got to figure out what my molecular weight is. And so chlorine was 35.46, and then hydrogen is 1.007. So I have 36.467 grams of hydrochloric acid. So I'm going to do that multiplication. So I have 36.467 or 0.46. Yeah, 36.467 times 0.342, 12.47. Grams of hydrochloric acid. And so 1 gram equals 1 milliliter, and so really the number of grams is going to be the same as the number of milliliters. So I have 12.472 milliliters of hydrochloric acid that I'm going to need to measure out in order to get my amount of product. And again, we use hydrochloric acid because that's our limiting reactant. And there, you can do a more in-depth problem of how you calculate your limiting reactant, but this is really just meant to supplement the titration video, and that goes a little bit deeper than is necessary here. But hopefully this helps just kind of give you a little review of stoichiometry and the idea behind it.